All right, so hello everyone again. It's C programming and it's about arrays. So let's start. Uh, Next slide, please. Come on, next slide, next slide. I am said next slide. Good, finally. So let's think about it, what we have to talk about this time. And it is about arrays, arrays, and arrays. Arrays? Actually, what we have done so far, creating and using structures and creating custom data types with type def, and now it's working with arrays. But this time I twisted it. So first we get into the dummies part. Hopefully it's more understandable, easier, and then we can get back to our original book, C Programming. So, learn C Programming by Jeff Suhai. Okay, let's start. So, we start with storing multiple variables in array. Then creating an array, understanding character arrays, sorting values in an array, working with multi-dimensional arrays, and sending an array to a function is the last topic. Well, maybe the last topic I shortened it. But anyway, let's see what we have here to talk about. Now, humans enjoy grouping things, as you know, mostly done by type. So people collect spoons, phone cards earlier, coins, and diverse things as well. So anyway, these items are easily grouped because they are of similar types. The C programming language as well has ways to group values of similar types. Like a row of variables in a query, and the word used in C array, C is array. So now as first one, avoiding arrays. At some point in your programming career, an array becomes painfully inevitable. So as an example here, listing 12-1, we will look at the code asks for and displays your 3 top scores, presumably from a game. Let's look at this code. Let's also run this code. Okay, so include stdio h, so the header we always use in main, int high score 1, high score 2, high score 3. Then printf your highest score. Then scanf %d high score 1. Okay, then again printf your second highest score. And we got again scanf with 2 here. And actually I can basically make this code happen here again. Third highest score and highest score 3 this time. Okay, and now puts. Here are your high scores. And printf. Okay, it's so. Okay, so here is the first one. And %d \n and high score 1. And then this one we can actually copy immediately for our purpose again. And we just have to change the numbers as always. But again, what if we have it for, I don't know, not 3 values, but for 10, for 50, for 100 high scores? Then it's going to be a bit of problem to continue the work in this way, right? So for this purpose, what we have right now, we see it, this is okay, but then again, if we have to continue, then it's going to be really hard for us. Okay, the code in listing 12-1 asks for 3 integer values. Input is stored in the 3 int variables declared. So here in line 7, then line 9 and line 11 in my case. Actually, I declare it in line 4. In the we could put it here, so line 5, just as the book also says. And then we have the output of these values in line 15, 16, and 17 together. Okay, now if I run this code and I get your high score, let's say 85. Still have some troubles here, and I don't know what exactly. So let me check again. Scanf and without an end, right? Without an end, I can use it for characters, but not for numbers. That was the mistake. Now it's corrected, and now it should work. Okay, there you go. Your second highest value and your third highest value is, and then we have all the numbers. So don't forget the end character for the scanf as well. So would it be a bit of issue to type a lot of numbers? Yeah, of course it would be. Well, but for the next exercise, let's modify the code to provide for 10 high scores. That would be fun, right? So anyway, let's not do that. Let's go back to our slides and let's see what we have here more to do. So we start with understanding arrays. An array is a series of variables of the same type, a dozen int variables, 2 or 3 double variables, or a string of char variables. The array doesn't contain all the same values. No, it's more like a series of copy holes into which you stick different values. An array is declared like any other variable. It's given a data type and a name, and then also a set of square brackets. And you see the following statement as high score, so int, high score, and square bracket. Now, this declaration is incomplete. The compiler doesn't yet know how many items or elements are in the array. So if the high score array were to hold 3 elements, it would be declared int high score and the brackets, hard brackets, and 3 inside the hard brackets. This array contains then 3 elements, each of them its own int value. The elements are accessed and assigned, as you see here, in this way. An array element is referenced by its index number, and that index number is in a square bracket. The first item is index 0, which is something you already remember. In C, you start counting at 0, which has its advantages, so that you already know it. Now, in the preceding example, we had the first array elements high score 0, and the assigned value was 750, and the second element was 699, and the third was 675. But it's always like high score 0, 1, and 2. So this is the second element, this is the third element. So after initialization, an array variable is used like any other variable in your code. So here you see as well where assigned value of high score 0 is then inside the var variable. This statement stores the value of an array element high score 0 to an int variable where if high score 0 is equal to 750, where it gets this value of 750 as well. Let's continue with exercise 12-3. Rewrite the source code from your solution to exercise 12-2. So using an array or described in this section. So let's do that this time. Exercise 12-3. Okay, I believe that our exercise 12-12 is actually nothing else but we have to add one more. Okay, so all right, then let's add one more. High score 4. Here as well, add one more. And here as well, add one more. And now we have all the 4 values. And let's see if this would work this time. And we have now 4 values. As you see, it works fantastically. Also, we can continue now with the next exercise, so 12-3. And it means that we have to rewrite it holding arrays this time. int high score. The length of the array, remember, is 4. And all this we can basically do with a 0, a 1, a 2, and a 4. So fourth with a 3. So fourth highest score. We got that, and this time we just have to do the same again. Two and 3, and I hope that this is going to work correctly. And this time I have to save it as exercise 12-3. Let's try to run it. And let's see what we have now. Okay, I got full values, and here are your high scores or highest scores. And all good. So we finished. And we can move on and continue with the next part. So there is another version of this. And the brute force solution has a stuffing each array variable individually. That's what we have done. So we continue and change this into loops. It gives the chance for the loop because we get through these versions, so that should be all right. Now that's why int x is given to get a for loop for x is 0. We start, then x is less than 4, and then we start the loop. And then all we need to do is to put this part inside, and your highest score, or actually your score is going to be like x plus 1, so the first one, second one, third one, and then we get scanf and x here, not here, but here, and then this time we can get rid of this part, and we can get rid of more than that, because here are your high scores. We look at them, and now again, for loop for x is 0, then x is less than 4, and x counted. Okay, so counter then 4, and we get into print f, and this is again %d, and %d backslash n x plus 1. So first, second, third, and fourth high score we need. That's why we add 1. And here we have the x value. And then all I need is to get the return. Okay. Now let's try to run it, and this is listing. So again, I have to save it in a different way. This is listing 12-2. Okay, here you go. Something is wrong here. High score. Okay, so not score, high score. Anyway, it's all good. It works fine. You see it here. So your first high score. I would actually put this here. So your high score 1. And 2 and 3 and 4. Perhaps better idea to have it in this way. Yep. And here are your high scores. Your high score 1, 2, 3, 4. All good, ready, finished as well. So most of the code from actually the listing 12-2, what you see here, should be familiar to you. And the only difference is the array notation. And you know why we use x plus 1 here? So in a printf statement in line 10 and line 16, here and here, in this way we can get 1, 2, 3, 4 instead of 0, 1, 2, 3. So although C likes to start numbering at 0, humans still prefer starting at 1. Okay, then we have actually finished with this exercise, so we can modify the source from listing 12-2 so that top 10 scores are input and displayed. Okay, I'll close this one. And here you see also that this is our exercise to do. Now let's do it. So let's change this. If it's top 10, we already know that the length should be 10. This is fine, and we have to change it to 10. This is also fine, and this value we have to change to 10 again. Is there anything else we need? I guess not. So let's try to use it. And before that, I also save it. As exercise 12-5 or -5. Okay, and I run it. And let's see what we have now. My high score 1 is, let's say, 60, then 58, then 68, then I don't know, 71, 75, 95, then 54, then 85, 97, and 61. So here we have them, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 printed out as well. Okay, that was not difficult to do. Don't forget, the first element in an array is always 0. And then when declaring an array, use the full number of elements, such as 10 for 10 elements. And even though the elements are indexed from 0 to 9, you still have the length of 10. The next step is to initialize an array. As with any variable in C, you can initialize an array when it's declared. The initialization requires a special format similar to the statement that you see here. The number in the square brackets isn't necessary when the initialization starts. The reason is that the compiler is smart enough to count the elements and allocate the array's storage automatically. Now we can do now we can do exercise 12-6. Write a program that displays the stock market closing numbers for the past 5 days. Use an initialized array market close to hold the values. The output should look like this here. Okay, let's get the values from there. Okay, so float market close and here are the values. So 24,164, 24,164.95, comma. This one we can delete. The next one is 2407.08. Yep. Come on. The next one is 24,643.63. 24,643.63. Then the next one is 24,400.93. Okay. And 23,972.8.53. Okay, in die. Then puts, where is it? Stock market close, stock market closing values, the previous 5 days. After puts, we don't need a new line, so we can use that. And then 4, and here we go, day, and day is less than 5, day plus plus, do the following. So print day D and point 2 F new line, and so day 1 plus 1, and here market close. Okay, market close day, and then return 0, and we are done with this one too. Actually, this is not necessary if we have only one single line to work with, so it should be completely okay. The only difference is that our program is told to be like this. I'm going to save this as exercise that 12-6, so save as. And let's try to run it afterwards. Okay, this is the mistake. And now we have all of them. Day 1, 2, 3, 4, 5. All the values are printed out. Okay, the next one is write the program that uses 2 arrays. The first array is initialized. Do we have it? Yeah. To the values 10, 12, 14, 15, 16, 18, and 20. The second array is the same size but not initialized. The code fill the second array with the square root of each of the values from the first array and output the results. Oh well, a bit of work to do. Let's do it. Okay, I'm going to take a new one. Include math h, and here, so told is, where is it? Okay, 1, 2, 3, 4, 5, 6, 7. So the length of the array is 7. That we could use as a constant because that's not never changes. So const int size or array size int first, so 10, 12, 14, 16, 18, 20, and then float second and size. Okay, and int x for the counter. The arrays are, and now we can use the for x 0 day, not x is less than size, and again x plus plus, and then here let's do second x is sqrt first x, and then okay, it says separated into 2 for loops, so let's do it. It's the same what we have to do here, so we do it in the same way. The square root of d is 0.2f, and next line. Actually, I could add a point here as well, and then first x and second x. And then it returns 0, and then it should be all right. Now this is exercise 7. Let's hope we have no mistakes. And you see it here, the square root of 10 is 3.16, then 3.46, and so on. So it seems to be working fine. So we can continue with the next assignment as well. Let's see what is next to be done. Playing with character arrays, so strings this time. All right, so strings. You can create an array using any of C language data types. Character array, however, is a little bit different when it's a string. As with any array, you can declare a character array, initialized or not. The format of an initialized character array can look like this. And this array declaration is for a 3-element character array containing the letters C, A, and T. This example is a character array, not a string. But the following one is a string. So anyway, the preceding array, so this one here, this time, declaration creates a string. The initialization text is enclosed in double quotes. Further, because a string literal is used, the compiler automatically adds the terminating 0 or null character, so \null. This addition is what makes the array a string and not a collection of characters. Very important detail here. So here's the same declaration written as an individual character, so you see here it works well. Okay, now let's see also how it works. So again, include stdio h and int main and char. Let's do that first. So char cat. C I T so let's see it. Okay, so put and cat, and then return 0 as usual. And then run it, and we got the cat here. Okay, but this is actually wrong. Wait, let me check. Printf. We get actually the same, right? But what if I add here at the end, as you remember, the character \0, and yet we get the same values here. Okay, so each array element in the this code this time in the preceding line is defined as its own char value, including also the \0 character that terminates the string. But now let's do again more. So the code listing 12-3 plot through the char array one character at a time. The index variable is used as well, the index, and the while loop spins until the \0 character at the end of the string is encountered. A final put char function kicks in a new line. Okay, so let's do that. Here we go with include, so hash include stdio int main, and the curve brackets we need char sentence, then now the square brackets we need random text int index. Index is 0. While sentence index is not \0. Do the following. Put char sentence index and index plus plus, so adding up the indexes, and then put char \n to add the new line and return 0 as the last one. Okay, this time we need to save it, save as, and listing 12 hyphen 3. And we are done, and let's see if it would work this time. Okay, we have a issue here. I'm not sure why it was there. And we got random text put on. Let's see if that would work in the same way where in the online C compiler as well. So what I get here, if I get the same here as well, I wonder. Okay, here we have another issue that says okay, all I needed to change is from the double quote mark to a simple quote mark. You see here, if I use the double quote mark, it doesn't put out, it doesn't display what I want. But if I use the simple quote mark, it brings up exactly what I wanted to show. So it works fine. Good. And now, so the while loop in this listing works like many string display routines found in C library. These functions probably use pointers instead of arrays, which is a topic later on. And again, here we could also use put sentence at the end. So line, which line is it? So 1, 2, 3, 4, 5, 6, 7, 8. What if I do the following? Puts sentence index. Yeah, it doesn't show what I want. What if I do put sentence? Now we got all the random text 10 times. And what if I do just S, new line, sentence here should be also the same. So I got here, oops, such a mistake again. Okay, so, oh, that's printf, obviously. And we got the random text again 10 times printed out. Okay, put cars. Sentence. Index is correct. Okay, now we can continue with our test here. Take a look at this code this time, and we got the random text as expected. So this one works as well. And the same way printf we just had before, so we don't need the while loop for that. We looped through, right, because it's a char sentence. So that's it. Printf, then again %s then \n, and sentence would also bring the same result to our work. That's it. But I would like to keep the original code of the loop, looping through, so we got the same, and this is done. All right, now let's continue with the next topic. Let's see what it is exactly. Working with empty character arrays. So just as you can declare an empty or uninitialized float or int array, you can create an empty character array. You must be precise, however, the array's size must be one character greater than the maximum length of the string to account for the terminating null character. Also, you have to ensure that whatever input fills the array doesn't exceed the array's size. And this is what we do now. Listing 12-4, the character array first name at line 5 can hold 15 characters plus 1 for the \0 or \null at the end of the string. This 15 character limitation is an assumption made by the programmer. Most first names are fewer than 15 characters long. Let's create this file again. Listing 12-14. So include stdio h int main char first name 16 and printf what's your first name. fget first name 16 stdin, then printf pleased to meet you %s \n and first name. And let's see, return 0. This time I'll have to save it again, listing 12-4. So dummies listing 12-4. And here it says, what's your first name? My first name is Roland. And pleased to meet you, Roland. Just keep it in this way, I guess. Okay. Right. We are good to go. So here, the fget function in line 8 reads in data for the first name string. The maximum input size is set to 16 characters, which already accounts for the null character because fget is smart that way. The text is read from the stdin, so the function third argument or the standard input. Good, we created it, we have run it, and let's try to type in more than 15 characters. And so my original family name includes this here as well, so I'm typing more than that. That was my original name, and pleased to meet you. And you see the remaining part is actually just trunked away, so it's no longer there. Okay, so even the enter key pressed isn't stored, which it would be otherwise when input is fewer than 15 characters. Okay, this time we have another task to do, and we can look at it here. That is exercise 12-10. Modify your source code from the exercise 12-9, which is actually the listing 12-4. That makes more sense to you. And the program also asks for your last name, storing this data in another array. The program should then greet you by using both first and last names. Okay, let's look at that. Code as well. So it's 12-10. We don't need this anymore. Okay, I'll get here inside. So let's do it. Char first name, char last name, and 16. What's your first name? And printf. What's your last name? And fget last name 16 and stdi in the same way. Pleased to meet you. And here we go with %s, and first name, last name. And let's try to run it. Okay, so what's your first name? Roland. What's your last name? Chismazia. And pleased to meet you, Roland Chismazia. This is how it would work. Now this is the output. And yes, the enter key press is stored as part of your name when you type fewer than 15 characters. This effect is how input is read by the fget. So the reason why it's separated here as well, you see, we got an enter because of the fget included. So if your first name is, for example, Dan, then it looks like, how is it? Okay, it's not written here. Well, anyway, so if it's Dan, then the new line lurks in the string because input in C is stream oriented and enter is part of the input stream as far as the fget function is concerned. So the fget makes it, and we have to fix this problem. And the way how we can fix it is using scanf. Okay. Okay, so if I include the following line, also you see here why first name X isn't the last character. You see what we have here. So I'm checking through the characters. So my first name is again Roland. My last name is, let's say, Lee this time. And you see Roland, so character 1, 2, 3, 4, 5, 6. And then character 7 is empty. And the reason why it's empty is, as I mentioned earlier, it's the enter. So here you see that we include the enter as well. It's the enter. So I got the result. Character 7 is empty. Okay, that's why. Okay, this modification I will also include, so save as, and this time it's anyway, this time it's now to the time has arrived to rewrite it and using scanf. Let's see that. Okay, and here scanf first name, right, but it's like this, so s, and we have a trouble, we have no length included, but let's look at it later. And then once again last name and scanf, and you see, remember, if you use numbers, always add an and. Here you don't need it to add an and because there is nothing like that. Last name, because there is no number in your name normally. So please to see you, and first name, last name, and return. And we are done. And now let's save it again quickly as a C file. And let's try to run it this time. And Roland Chismazia, and we have no problem anymore, right? You see that? And what if I keep writing my first name and I get rid of the last name now? So just use first name only. Let's look at this, and I write it again the same way. Roland Attila Chismazia. See, we have a trouble. It should cut at 15, like 15, but it's not doing it. So let's see what the problem is, or how could we solve that. The problem with scanf function is that it doesn't check to ensure the input limit is 15 character long. That is, unless we include it. And now let's include it in a way like you see here, 12-12. So let's do it. And we need to include it. Okay, 15s, and also here 15s, but now let's just keep it in this way first, and let's try to run it. And I also have to change the name of the file, 1212. And now let's try to check it. Roland Attila Chismazia, and it stops there. That's exactly what we wanted to see. It stops there. Good job. Okay, so we can now fix this issue as well. One more time. S, first name, last name. and it should work this time. So Roland Lee, oops, so done, and pleased to meet you, Roland Lee, done. It works fine. I see that, you see that we can actually continue with the next exercise if we still have any to do. So the percentage 15 as conversion character task, the first scanf function to read only the first 15 characters of input and place it into the char array, so string. Any extra text is then discarded. Alright, so here actually I also stop because we have a time frame of 1 hour, and then the remaining part you will see later. Thank you very much for your attention and see you the next time. Bye for now.